Hey everyone, in this video we're going to talk about immunization strategies for a portfolio of bonds, Chapter 21. There is a mini exercise associated with this video, which we'll talk about later. So let's get into it. Chapter 21. We'll also continue working on the April 2nd duration and immunization spreadsheet that we've had open the last couple videos. So immunization is a strategy to manage interest rate risk, usually in the context of some kind of company that has a stream of liabilities and then some assets to match those liabilities. So like an insurance company has a stream of future liabilities paying out claims to policyholders. And then suppose they've got those liabilities have a present value of $100 million, right? That's the present value of all the future liabilities they have to pay out. And then they'll match that liability stream with the portfolio of assets with a present value or a market value of $100 million. So immunization tries to set the interest rate sensitivities of those two things equivalent to each other. And so that involves matching duration. So let's take a look at how it works with the spreadsheet that we've been looking at. We've got this portfolio of bonds that has a modified duration of 4.048. You can interpret that, right? A 1% change in interest rates is associated with a 4.048% change in the value of this bond portfolio. Or in other words, a 100 basis point change in interest rates is associated with a $531.81 change in the market value of the portfolio, right? So what we're going to do is create a portfolio of these three bonds to match this liability stream, right? And let's see, we know how to find the present value of this liability stream. We could use the NPV function. It's also just one cash flow. So if you just take the present value of that $10,000 cash flow 4 years from now, these liabilities are worth $7,350 today, right? We talked about the Macaulay duration of just a single cash flow, like a zero coupon bond. 100% of this liability stream's cash flows happen at year 4. So if you look back at the weighted average maturity of this liability stream, it's just equal to the one cash flow. You could plug in the liability stream to the Macaulay duration formula and take the weighted average like we did earlier, and you come out with the Macaulay duration of exactly 4. So the duration of the Macaulay duration of this liability stream is 4. Remember, the modified duration is just the Macaulay duration divided by 1 plus the discount rate. So here's modified duration. D star is Macaulay duration divided by 1 plus the yield to maturity. And then Macaulay duration is up here, right? If you did this whole formula for that liability stream, you'd get 4. But if we take the Macaulay duration divided by 1 plus the discount rate on the liabilities, which is assumed, we've got a modified duration of 3.704, right? And then if we find the dollar duration, remember that's the modified duration divided by 100 times the present value of the liability stream. So a 100 basis point change in interest rates is associated with a $272 change in the present value of the liability stream. So our goal is to create a portfolio of bonds that can fund this liability stream, right? And let's see how that works actually. So I've got a simple portfolio where suppose we buy just 6,910 in par value of bond C. What we end up with is a portfolio whose market value is about equal to that of the liability stream, right? So we've got one bond worth about the same as the liability stream, one asset to match the liability. Problem is the durations of the liability stream and the bond portfolio are much different. You can see the bond portfolio has more interest rate risk than the liability stream. And so I've set this spreadsheet up such that, okay, if all the discount rates in the spreadsheet are tied to some yield curve shift cell reference, right? So suppose interest rates rise by 100 basis points, right? Suppose interest rates rise by 1 percentage point. That'll decrease the present value of the liability stream by about 3.7% or $272.23. Let's see what happens there. Yes. And then It will also decrease the present value, the market value of the bond portfolio by about 6.3%, so by more. So if you look down here, we've got some diagnostics to see whether the liability stream is immunized or the bond portfolio is immunized. All right, so the difference in durations is not equal to zero. The portfolio market value for the bonds is close to that of the present value of the liability stream right now. But we can see if interest rates rise by 1 percentage point, now the liability stream is worth 7,084, but the bond portfolio is worth only 6,910. So now the market value of our assets, our bonds, is less than the present value of the liability stream. So our bond portfolio is no longer sufficient to cover the liability stream. So in order to avoid this interest rate risk, right, this is interest rate risk, so that now these assets are no longer sufficient to cover this liability stream. In order to manage this interest rate risk, we need to create a bond portfolio with the same duration, modified duration as the liability stream, and also the same market value. So in the next video, we'll go over how to do that. And then as far as a mini exercise, I'd really just like you to find a Wall Street Journal article on changes in interest rates and bond markets and bond yields. And there's details under mini exercises. So thanks for tuning in. In the next video, we'll find an immunized portfolio so that these bonds will be immunized to changes in interest rates. Thanks.